Good morning, children. Today I am going to start a new lesson, that is P block elements. This chapter consisting of 15th group, 16th group, 17th group and 18th group. Okay, in this chapter we will learn about the elements, which are all elements present in the 15th group, 16th group, 17th group and 18th group, and what is their general chemical properties, and in that particular group what are the properties of that elements, properties of compounds will be discussed. So now let us start. See, I will explain a brief introduction about all the groups, and next class onwards we will be going to in each group in detail. Right? So 15th group elements. 15th group elements are nitrogen, phosphorus, arsenic, antimony, bismuth. These are the 15th group elements. Next 16th group: oxygen, sulfur, selenium, tellurium, polonium. Next 17th group elements: fluorine, chlorine, bromine, iodine and astatine. And 18th group elements: helium, neon, argon, krypton, xenon, radon. These are the elements. Now let me write the atomic numbers of these elements. Let me write the atomic numbers of elements. Nitrogen, atomic number 7. 7 plus 8, 15. 15 plus 18, 18, 33. 33 plus 18, 33 plus 18, 51. 51 plus 32, 51 plus 32, 83. These are the atomic numbers. The same way, oxygen, atomic number 8, sulfur 16, 16 plus 18, 34, 34 plus 18, 52, 52 plus 32, 84. Even the same, fluorine also same, fluorine atomic number 9, chlorine 17, 9 plus 8, 17, 17 plus 18, 35, 35 plus 18, 53, 53 plus 32, 85. Even the same hydrogen atomic number 2, neon 10, argon 18, krypton 36, xenon 54 and radon 86. These are the elements present in their respective groups. 15th group: nitrogen, phosphorus, arsenic, antimony, bismuth. 16th group: oxygen, sulfur, selenium, tellurium, polonium. 17th group: fluorine, chlorine, bromine, iodine, astatine. 18th group: helium, neon, argon, krypton, xenon, radon. Right? These are the simple and general information, children. Now I'll write the electronic configuration. Right? Nitrogen atomic number 7. Electronic configuration: 1s2, 2s2, 2p3. See here, if I write 1s2, 2s2, 2p3, check. 3 plus 2, 5, 5 plus 2, 7 is correct. So now 15, if you write 1s2, 2s2, 2p6, 3s2, 3p3. Now what I am going to say: 2s2, 2p3, 3s2, 3p3. Next, if you keep on writing 4s2, 4p3, 5s2, 5p3, 6s2 pp. So in this, the valence shell, general valence shell electronic configuration is ns2 np. What it is? The general valence shell electronic configuration. The same way, the 16th group also once I will show you. Oxygen atomic number 8 electronic configuration 1s2, 2s2, 2p4. So the general valence shell electronic configuration is ns2 np4. Now 17th group elements the same way, ns2 np5, ns2 np6. What this is ns2 np4? I tell you what is ns2 np3 means. N means orbit number or shell number. This is called principal quantum number. First orbit means n value 1. Second orbit means n value 2. Third orbit means n value 3. Like this. ns2 np3, ns2 np3, ns2 np4, ns2 np5, ns2 np6. ns2 np6 already 8 electrons are present in the valence shell, so they are most stable. 18th group elements are most stable. And what we call 15th group elements are called nitrogen family. As the nitrogen is the first element, you can call it as nitrogen family. Nitrogen family. Or it is also called pinicogens. As P is silent here, I can call it as nicogens. 16th group elements are called oxygen family are chalcogens. 17th group element fluorine family are halogens. And 18th group elements are called zero group noble gases or inert gases. You can call it as zero group elements or noble gases or inert gases. Right? If we learn about these elements, this chapter is completed. Right? See for example, here almost all the periodic trends and all same. See, sir, what are periodic trends? I'll tell you. Okay, generally at a time all the fourth groups, 15th group and 16th and 17th and 18th. I am reminding you once again, 15th group elements are called nitrogen family or nicogens. 16th group elements called oxygen family or chalcogens. 17th group elements are called halogens. And 18th group elements are called noble gases or inert gases. Now, the general valence shell electronic configuration. General valence shell electronic configuration or valence shell, outermost shell or valence shell, whatever it is, same only. Outermost shell or valence shell. Valence shell electronic configuration is ns2 np3, 2s2 2p3, 3s2 3p3, like ns2 np3. For 16th group, ns2 np4, 17th group, ns2 np5, and 18th group, ns2 np6. Understood? ns2 np3, 3 plus 2, 5, 15th group. 5 valence electrons are present. 6 valence electrons are present in 16th group. And 7 valence electrons are present in 17th group. And 8 valence electrons are present. 8 valence electrons are present. 8 valence electrons are present. 8 valence electrons are present in 18th group. Right? Okay. So, generally valence, when we are talking about the valency, the combining capacity of an element, 8 minus 1, that is 3. 8 minus 6, 2 is the valency. And 8 minus 7, 1 is the valency. And here the valency is 0. These elements are more stable. These elements cannot combine with other elements. Already they are stable. In the valency shell, 8 electrons are present in them. And see these elements, if you see the electronic configuration of fluorine 9, 1s2, 2s2, 2p5. Here in the valence shell only 7 electrons are present. 7 valence electrons are present. So they are eagerly waiting for one more electron. Okay, means they have tendency to gain one electron. That is called electron gain enthalpy. These halogens, they have a tendency to gain one electron. Okay, these are the elements, 16th group elements, they have the tendency to gain 2 more electrons. Okay, 4 plus 2, 6 valence electrons. So they try to gain 2 more electrons. That's what the oxidation state of the 16th group elements are -2. Oxygen, most of the compounds, they show -2 oxidation state. And 17th group elements, they show -1 oxidation state. F -1, Cl -1 like this. They show -1 oxidation state. Why? Because they have only 7 valence electrons in their valence shell. They try to gain 1 more electron so that 8 electrons will be there in the valence shell. If they gain 1 more electron, they get 8 electrons in the valence shell. So for that purpose, they gain 1 more electron. 17 group elements. And the general periodic trends I am explaining, check once. From top to bottom, the atomic size always increases. From top to bottom, the atomic size increases. From top to bottom, in a group from top to bottom, the atomic size goes on increasing. Why atomic size goes on increases, sir? See, number of shells are increasing. From top to bottom, as the number of shells are increasing, the distance between the center of the nucleus to the valence shell also increases. The distance between the center of the nucleus to the valence shell also increases. That means atomic size from top to bottom increasing, or atomic size from top to bottom increasing. What is atomic size or atomic radius? The distance between the center of the nucleus to the valence shell. As the number of shells are increasing from top to bottom, okay, the atomic size is also increasing. Right, children? Atomic size or atomic radius is increasing. And what about ionization potential? What is ionization potential? The amount of energy required to remove 1 electron from the neutral isolated gaseous atom. See here, from top to bottom, the ionization potential decreases. Why? Because the number of shells are increasing, the size is increasing. The last electrons are weakly attracted by the nucleus. So we can easily remove electron. Just by giving little energy, you can remove electron. Means what? From top to bottom, ionization potential decreases. And atomic radius and ionization potential are inversely proportional. Atomic radius or atomic size is more, ionization potential automatically less. Ionization potential and atomic size are inversely proportional. Atomic size is more, ionization potential is less, inversely proportional. Why atomic size is increasing? If atomic size increases, why ionization potential decreases? Means if atomic size increases, the last electron is weakly attracted by the nucleus. Here you can see the last electron is weakly attracted by the nucleus. So we can easily remove outermost electron. So in a group from top to bottom, ionization potential always decreases. And electronegativity from top in a group, you take any group, electronegativity from top to bottom decreasing. The highest electronegative element is fluorine. These are the normal trends, children. Even electron gain enthalpy, one more property, electron gain enthalpy. Even electron gain enthalpy values. Electron gain enthalpy values generally from top to bottom onwards decreasing. Electron gain enthalpy values from top to bottom decreasing. But here, in case of fluorine, the electron gain enthalpy of fluorine is higher than fluorine, that we have studied in class 11th. Why the electron gain enthalpy of fluorine is more than fluorine means the electron gain enthalpy of fluorine is more than electron gain enthalpy. First thing, what is electron gain enthalpy? Electron gain enthalpy means the amount of energy required or released, or we can say the enthalpy change when one electron is added to the neutral isolated gaseous atom. When one electron is added to the neutral isolated gaseous atom, okay, the enthalpy change. Generally we see the enthalpy change when one electron is added to the neutral isolated gaseous atom. I'll show you how it is. When one electron is added, when one electron is added to the fluorine, we get F minus 1. So when one electron is added to the neutral isolated gaseous atom, the amount of energy released or the amount of energy required, that is called as electron gain enthalpy. Generally, other than inert gases, the remaining cases energy will be released. Whenever we add one electron, most of the cases energy is released. Okay, but here 18th group elements, if we wanted to add one more electron, more energy is required. Energy is required. Okay, so here try to understand the concept here. This for example, 17th group elements, electron gain enthalpy values are negative. Delta H is negative. Why? Because energy is releasing. So electron gain enthalpy for example 17th group elements, it is negative. Energy is released. Okay. In case of 18th group elements, electron gain enthalpy values are positive. Means amount of energy required to add one electron. Okay, electron gain enthalpy values from top to bottom onwards decreasing. But in case of chlorine will have high electron gain enthalpy than fluorine. Yeah, children, this is the general characteristic properties will be same, whether it is 15th group or 16th group or 17th group or 18th group, right? So here today I explained about the general characteristic properties and valence shell electronic configuration of elements. I explained. In the next video, okay, we'll go to the individual groups, 15th group. Okay, what are the elements present in them and what are the general properties, and we will discuss the compounds of nitrogen and compounds of phosphorus and their chemical properties. I hope you understood, children. Okay, thank you.